Today, we'll look at an open source project called Helix, which allows you to build native Ruby extensions in Rust. To show you what it can do, we'll build a simple Rails application together. As you can see, this app called Flipper does one thing and one thing well. You can type into this box here and it will translate it into Australian for you and vice versa. Obviously, it's very important for something like this to be very fast and very robust. Therefore, we're going to build a core functionality in Rust using Helix and try to use the native extension inside our Rails app. We'll start by deleting everything and starting over. Whoops. Next, we're going to generate a new Rails app. We're not going to need a database for this, so we're going to skip active record. Whoops, it worked. To make sure everything is really working, we'll quickly start the Rails server and check it in the browser. We'll navigate to localhost 3000, and as you can see, we're on Rails. Seems good. To start using Helix, we'll add the Helix Rails gem into my gem file and run a bundle install. One of the things we get from the Helix Rails gem is a generator, so we are going to use that to create our first Helix project. We can run that by typing Rails generate helix:create, followed by the name of the native extension. In this case, we decided to name it text transform. So that generated a bunch of files for us, and let's take a look at those in our editor. As you can see, there's a crates directory, and in there's our text transform native extension. Of course, a native extension is just a Ruby gem, so there's a gem spec for it. However, this is also a Rust project, so there's also going to be a cargo.toml, which, if you're not familiar, is like the gem file, the gem spec, or package.json for a Rust project. Like any regular gem, there's a lib directory for our Ruby files, and there's also a source directory for our Rust files per the usual convention. Now, this librs file here is the main entry point of a Rust project. What you're looking at here is a very basic Ruby class written in Rust. The Rust macro system allowed us to create a DSL that should feel pretty familiar to both Rust and Ruby programmers. We can test this out in action by going into our project directory and running ric-irb. Since this is the first time we're running our code, it would automatically compile Rust code and package that into a native extension that Ruby can require. When everything is done, we'll be putting an IRB prompt and we can use this to test our native extension. We can do that by typing text transform.hello. As you can see now, we're seeing the message we printed from Rust. That's how much work you have to do to get to hello world. That's not a lot. That being said, hello world is not that interesting, so we'll start implementing the functionality that we're after. Now, as you might have heard, TDD is dead, so we'll do some BDD with rspec instead. After a quick bundle install, we're ready to write our first spec. We'll do that by creating a spec folder as well as a text transform spec.rb. Whoops, look at all the things that I'm not doing. Alright, okay, I cheated. I pasted in some code, but it's pretty basic stuff. We're expected to define a class method called textTransform.flip. If you pass an English string, it's going to flip it to Australian, and if you pass Australian, it's going to flip it back to English. If we run the test now, it's going to fail because we haven't implemented that method. So let's go ahead and do that. We'll delete the placeholder hello method and replace that with our flip method. Because Rust is a typed language, we have to say that it takes a string and returns a new string. By saying that, the Rust compiler can check your code to make sure it's actually returning a string. And also, Helix can use that information at runtime. If your user try to pass you a number or nil, they will automatically get a Ruby type error, so you don't have to worry about any of that in your code. Whoops, look at all the code I'm not typing again. By using Helix, you can just copy and paste code all the time instead of writing your own. It's pretty amazing. Now this might look like a lot of code, but the bulk of it is just a very big lookup table. All we're doing here is taking a Rust string, looping through each character, reversing them, mapping each character into its flip version, and then finally joining the characters back up into a string. If you look at the code, you'll notice that we're using a lot of high-level features here, such as iterators and blocks. Now, this might sound suboptimal, but the Rust compiler will be able to see through all of that and generate highly optimized machine code that could even outperform your carefully handwritten loop. Alright, so now that we have written the code, let's run the test again. Whoops, it didn't work. It's still not finding the method that we've just defined. This is because Rust is a compiled language, therefore, every time after you make a change, you will have to recompile your code. We can do that by running ric build, and after that you can see that our tests are now green. Luckily, the Rust compiler is pretty fast, so we're not going to spend a lot of time waiting for code to compile. That being said, having to remember to compile your code every time is pretty error prone, but we can automate that with a ric task, which you're probably going to do in your project anyway. The trick here is to make ric build a dependency of your spec test, so every time you run it, it will first make sure your project is compiled correctly. And to show you that workflow, let's try to add a new feature. It can flip table. As you can see, this is a pretty simple feature. If you give it table, it'll flip it. If you give it flip table, it'll flip it back. So now we can try running our tests again with RigSpec, and they're failing as expected. With the test in place, we can go ahead and implement our feature. This is going to be pretty straightforward. We're just going to have a conditional at the top to check for the special cases. Going back to the terminal, you can see that by running RigSpec, it automatically rebuilds our native extension. Therefore, everything just worked. Hopefully, this exercise gave you an idea of how easy it is to build safe and highly performant native extensions with Helix. There are a lot of cool features that I didn't have time to cover here. You can check them out on the website. But we're not done here. As promised, we're going to use this extension in a Rails app and deploy it to production. So let's do that. Here in the jump file, you can see that the Helix generator has already added our native extension as a dependency. Because Rails will automatically require all your dependencies unless you told it otherwise, we can just go ahead and use our flip method anywhere in our app. We can start by adding a RESTful resource to our router, and because this is the only feature in our app, we can map that to a root URL. The create and index actions are all we're going to need here, so we specified that as well. Next, we're going to add a controller. We're going to call this the flips controller to map the name of a resource. As usual, I'll paste some code here, but once again, it's pretty straightforward. In the index action, I'm setting the text field to query param or otherwise defaulting it to the string hello world. In the create action, we'll take the string that was submitted through the text field, pass it to the native extension, and put the final result back into the text field. Finally, we'll create a template to tie all of these together. Following the Rails convention, we'll create a flips directory and create an index.html.erb file for our template. Because we were following the Rails conventions, all we'll need here is a simple form with a text field and a submit button. We can see this in action by running the Rails server again. As we refresh the page, you'll see a beautifully designed form. If you click the button, hey, it actually works. And remember, all of these are actually happening inside native extension written in Rust embedded inside Rails app. Heck, we even wrote tests and we're barely 7 minutes in. Admittedly, this is primarily because I talk really fast, but we should also give Helix some credit for making this really easy. Before we wrap up, there's one more thing, and that is to deploy this to production. Fortunately, Heroku made this really easy, so this is going to take no time at all. We'll start by committing our work, which is probably a good idea anyway. Next, we'll create a Heroku app for this, and we'll call it Helix Flipper. Usually, Heroku automatically detects and configures your programming language. However, in this case, because we're using Rust and Ruby together in the same app, we'll have to set that up manually. First, we'll install the Rust build pack. After that, we can install the Ruby build pack that you're probably familiar with. At this point, we're basically ready to deploy. We can do that by running git push Heroku master. This is our first deploy, so the Rust build pack will automatically download and install the Rust toolchains that are necessary for compiling our native extensions. After that, the Ruby build pack will install the Ruby dependencies as usual. At this point, we have everything we need to build our native extension. Cargo will automatically download and compile any Rust dependencies we have. After that, it will compile Rust code into the format required by Ruby. With that, we've finished our deploy and our app is now available on the public internet. Let's check it out. If you want, you can follow along by going to helixflipper.herokuapp.com. And boom, there we go. As you can see, everything is working and we now have our Rust native extension running on the public internet inside Rails app. I hope you enjoyed this demo and you're excited to give Helix a try. As I said earlier, there are a lot of information I couldn't cover here, but you can find them on our website at usehelix.com. I think Helix has a lot of potential and I can't wait to see what you're going to build with it. Thank you very much for watching.